So yesterday we did disk method. Okay, yesterday we did disk method, right? Disk method we use for completely solid objects. If something is a 100% solid, we use disk method, okay? But sometimes some things aren't solid, right? For example, this guy right here, right? It's got a hole in it, right? It's got a hole, the tube, right? So we can't use disk method. Disk method won't work because disk method assumes that it's 100% solid. So when we're looking at things like that, or things like this guy here, it looks like a cup or a tub, but it's got a hole in it, right? So it's not completely solid. Something like this too, same kind of thing, just turned on its side, right? This is when we use what's called washer method, right? Washer method. The reason it's called washer method is because what we're going to do is we're going to do the same thing we did yesterday. The same thing we did yesterday, right? One of those discs, find one of those discs, and then add up all of the discs together, okay? So yesterday was a disc because it was completely solid. It was completely solid like a Frisbee, okay? Today, when we do that, it's not going to be completely solid. It's going to look like something like that. It's going to look like a washer. That's why it's called the washer method, because it looks like a washer, like a metal washer. Okay? There are two ways. Again, there are two ways. dx is when we're going like this, right? Yesterday, if we were going over, if we were revolving this way, it was dx, right? That stays. If it revolves this way, it's dy. Okay? Same as yesterday. That part's the same. The new part, the big part today is r means radius. Okay? The r means radius. So yesterday we had a radius. We only had one though. Today we're going to have two. We're going to have a big R and a capital R and a little r. Why? What are the differences? This right here. One is for the outer boundary. One is for the inner boundary. Okay? Still top minus bottom or right minus left. If you're talking dy, it's going to be right minus left. Okay? Same as yesterday. All right. But like I said, the shapes are going to look different. The shapes are going to look different. Let's see. I have my... Let's see if I can get this. No, it won't let me. Yeah, it won't let me. There's a video like I showed you guys yesterday of what it looks like. How did I do that one? Let's see. Let me see if I can pull it up. Of how these things are created. Because again, they're not going to give you the 3D shape. You're going to have to visualize that in your head, what it would look like, right? They're never going to say, find the area of that. What they're going to say is, or find the volume of that. What they're going to say is, when that guy revolves around the x-axis, you're going to have a shape, and it's going to be a volume shape. And you're going to have to find volume of that. Okay? So I want to show you how the shapes are created and why are they missing things on the inside. Give me 1 second there we go. Nope, didn't work. Let's see here. There we go. Okay, so there's the shape. There's the lower bound. There's the outside bound, so there's the area. And now it's going to revolve. When it revolves, it creates a hole in there, right? It creates a hole we didn't have yesterday. But now we're going to have that hole, and we have to take that into account. So when we find one of these slices, it looks like a washer. That's what we're doing. That's what our formula today is going to do. So when I talk about, big R and little r, right? Focus up here. When I talk about big R and little r, because this is big, there are two circles here, right? You see two circles? You see a big circle and you see a little circle. The radius of the big circle is big R. The radius of the little circle is little r. That's why we have two r's, right? Yesterday we didn't have that. We just had one circle, okay? Right. Okay, so, all right. So, let's look at number one now. Let's look at number one. For the washer method, it's critically important that you have a picture to look at and not on your calculator, an actual picture. It's critically important because it's going to help you. It's going to be vital that you have something to write on. Okay? So every problem that you do, I would 100% implore you to draw a picture, because once we do the process, I don't know how you would do it without a picture. Okay? Because it's difficult. Even if you have a picture on your calculator, you can't draw on that. So I don't know how you would do that. So like I said, 100% start with a picture. So I want you to draw the picture. Draw the picture. Tell me where the bound is. I want to know. Draw the picture so I can see the bounded area. Draw the picture so I can see the bounded area. Find the volume of the solid created by revolving the region enclosed by y equals x squared plus 1, y equals 2, about the x-axis. About the x-axis. That's where it's revolving. It's revolving about the x-axis. The x-axis is right here. So that means this green little thing, this green region is going to revolve around, however you want to look at it, it's going to revolve around this and create a 3D shape. It's going to create kind of a donut with an edge. Okay? There's a hole in the donut, right? There's a hole in the donut. That's why it's a washer method problem. Okay? Like I said, so we have to find volume for a shape that doesn't exist. That's the difference between calculus and every other thing, right? Every other time you find volume, you can see the shape. Oh, it's right there. Doesn't exist, right? It doesn't exist. We have to kind of visualize what it looks like. This green thing's going to revolve around and around and around until it creates a 3D shape. Okay? So it's going to have a hole in it. Because it has a hole in it, we have to use washer method. Washer method. That's one of the big things, because on the test, I'm not going to tell you if it's a washer method or if it's a disk method. By the graph, you're going to have to know. Will there be a hole in it or will there not be a hole in it? Okay? So that's one of my questions for you guys. How do we know if there's going to be a hole in the graph or not? How do we know if there's going to be a hole in the 3D shape or not? Okay? All right, so again, as we're doing this, I highly suggest don't wait for me. Don't wait for me. A lot of you sit there and, oh, Mr. Flores wrote down something. Let me write it down. Think for yourself. You guys can do this. You guys have been in this class all year, right? You guys are all very smart. Don't wait for me. If you're waiting for me to do everything, you're not going to be able to do it when it's time to come. Okay? The students who do well, the students who get A's on tests are the ones that don't wait for me. They're just like, and if you do make an error, then you can wait for me, right? But don't wait for me for everything. Kind of start getting it going in your head. What am I going to do? What am I going to do? Okay? All right. So we know that's going to be big R minus little r. Is this going to be dx or dy? Dx, because it's revolving this way, right? Just like yesterday. If it revolves this way, it's dx. So we need everything solved for y. Okay. So this is how you're going to do it. This is how you figure out big R and little r. We'll do big R first. Big R. So this part I need you to watch because this part we haven't done before. The parts we've done before, you can do that on your own, but this part we haven't done before. So watch this. So how do you find big R? You start with where it's revolving around. It's revolving around the blue line, right? So I'm going to make a dot on the blue line. Okay? You're going to go from that dot up until you reach the top of the area, the green area. It's green on my paper. Okay? So I'm going to go up, straight up. And when I hit the top of the green, I'm going to stop and make another dot. That is big R. That is your radius for big R. So what did we say was big R? Mm-hmm. No. What did we say was for big R? Top minus bottom, right? Top minus bottom. So we're going to go red minus blue. Red minus blue. Okay, so now let's look at red. What is red? Y equals 2. Good. What is blue? Good. So how do we write that in my problem? 2 minus 0, which is just 2. Okay? That's big R. How do we do little r? So watch this too. Little r. Same thing, start at the bottom, except we're not going to go to the top of the green. I'm going to go to the bottom of the green and stop before I hit the green, right? That's little r, right? So this guy is big R, this guy is little r. Okay? Again, top minus bottom. What is the top? X squared plus 1, right? Y equals x squared plus 1. What is the bottom? Y equals 0, right? So how do I write that in here? Mm-hmm.
X squared plus 1 minus 0, but that's just going to be x squared plus 1.
Minus 0? Yep. Mm-hmm.
Plus 1. Actually.
Plus 1. Okay. One more thing, the bounds. The bounds. Well, it's dx, so our bounds are from left to right. What are the bounds of the object created, this green stuff? Well, we got a dot here and a dot here. Looks like where the where the red and the black cross. X equals 1. X equals negative 1. Okay. When I put anything into my calculator, I like to simplify it because I don't want my calculator to make mistakes. So over here, this is just 4. And this is going to be x squared plus 1 squared. 2 minus 0 is 2. Squared is 4. So anytime I put anything into my calculator, I want to make sure it's simplified as much as possible because I don't want my calculator to make mistakes. Your calculator doesn't make mistakes, but sometimes you miscommunicate with your calculator, okay? And your calculator doesn't get a grade on the test. So a lot of times people are like, oh, but my calculator's set. Well, yeah, sorry, you know. So you want to communicate as clearly as possible with your calculator. Okay, so to do that, I always simplify before I put anything into my calculator. Don't forget the pi in the front. Either do the pi first or do the pi last. Just don't forget about it like I did yesterday. Because on multiple choice tests, both answers will be there with and without pi because they know where students make mistakes. 4 minus parentheses x squared plus 1 squared. Yep, looks good. Times pi. 13.404. 13.404. So approximately, so the volume of that shape that doesn't exist would be 13.404 approximately. Okay? That's essentially how we're going to do every single problem. That's essentially what we're going to have to do every single problem. But to do it, like I said, you need something to draw on. You need something to draw on because without it, it's going to be hard because it's so much easier to see what the top and the bottom is, right? Some of you might be able to do it with a calculator, but I don't take that chance. I always draw, okay? All right, so I want you to do number 2 now. I want you to do number 2. If you need to redraw, take the 2 minutes to redraw. It's time well spent. If you can use one picture for a couple problems, that's okay too, but like I said, sometimes you need to redraw. Okay, so the 2 graphs that are bounded are the same, but the revolution, the axis of revolution is different. It went down, so it's farther away. So it's not going to be exactly the same. So big R extends from the axis of revolution to the top of the green, of the area. The bottom one goes from the axis of revolution, little r goes from the axis of revolution to before the green. If you touch green, you went too far with little r. If you didn't touch green with big R, you're not far enough. Okay? Those represent the top and the bottom. Okay?
Isn't it all x squared plus 2?
Plus 2, plus 2, plus 2.
Subtracting by -1.
Oh, so I forgot you're right, I forgot the negative. So that would be plus 2 squared. Yep, thank you. Okay. Simplified it a little bit as much as I could. Bounds are the same because it's the same green. Nothing's changed there. So we go and -1, +1, 9 minus x squared plus 2 squared times pi. 21.712. 21.782. Sorry, 782. 21.782. There we go. Okay. So tell me, if I'm doing a graph, so we've seen 2 graphs. I know they're the same graph, but we've done 2 graphs. So if you look at a graph, how do we know if we use washer method or how do we know if we use disk method? What are these graphs? How are these graphs that we did yesterday different than the two that we did today? What's the differences between them?
So these graphs have a comparable distance between the one they're revolving around rather than the one we did before.
Exactly, 100%. These graphs are not touching the axis of revolution, right? The blue is the axis of revolution. The green is the stuff. It's not touching. They're not touching. There's a distance between them, right? Yesterday, the axis of revolution for this guy was the yellow. The green is touching it, right? The one before that. The axis of revolution was the orange. The green is touching that. The axis of revolution was the pink. The green is touching that, right? It's touching on all of these that we did yesterday, the green and the axis of revolution. Today, it's not. That's creating the hole. That's creating this hole that you see in there, right? That hole in there, that's what creates the hole, that tube in there, okay, where there's nothing. Okay, so that's how you can tell. You can tell by looking at a picture which one it's going to be. Okay, so all of these today are going to be that. But on test day, it's going to look like this, and you probably won't have a picture to look at. You'll have a calculator, but you won't have a picture to look at. I always suggest having a calculator or you getting a picture to see which one you're going to do. Okay? Okay, so number 3. Let the region R be the area enclosed by f of x, the horizontal line y equals -2, and then the two vertical lines, x equals 0 and x equals 2. Find the volume of the solid generated when R is revolved around y equals -4. Okay, so what I want you to do now is draw a picture. Draw a picture. And if you want to solve it, go for it. But I at least want you to draw a picture. If you're going to use the calculator, it's okay, but I want something on paper too. So I don't care how you do it. Show me something on paper, though. You can use the calculator. Sometimes what people do is use the calculator and then sketch it. That's fine. But today you really want something on paper because it's very helpful. From past experience, it's very helpful. Okay, that's what it's just a sketch. It's not anything perfect. Just as best as you can, especially with E, because E, we have a lot of decimals with E. If you graph E on your calculator, oops, nope. If you graph E on your calculator, it'll give you a table. If you go to that button that says table, top right-hand corner, you go to table, boom, there's a table of values. So it makes it, why isn't it? There we go, table of values. Okay, so this area is not very big. It's not very wide, but that's the area we're looking at there. Okay. Right. The axis of revolution is -4, y equals -4. So that's where we're extending from. Okay. That's where we're so you can see the gap here. The axis of revolution and the green are not touching, so it's going to be washer method. Okay. Wait. The blue, actually the green extends a little further down. I just saw that right now. Let's see.
Yeah, it extends
All right, so the green's going to extend a little farther down. Okay. Still not touching. Still the green is not touching the blue. Okay, so it's washer method. Once you have a good visual, the rest of the part's easy because you just set it up and then you use your calculator. Pi, big R squared minus little r squared. This is a dx since we're revolving over a horizontal line. Okay. So let's start with big R. Big R goes from the axis of revolution, the blue line, and it extends up until it goes past the green. Once it passes the green, right there. Any further and I would go past the green. I don't want to go past the green. So that's big R. Big R goes from, so the top dot is f of x, e to the x, minus the bottom dot, which is at -4. Okay. Little r. Starts in the same spot, but goes up until it hits green. Once it hits green, it can't go any further. The top there is going to be -2. Minus -4. The bounds were created for you. The bounds are here and here. So 0 to 2. Okay, e to the x plus 4 squared minus 2 squared, which is just 4. Okay. Calculator does the rest. So we go from 0 to 2, parentheses, e to the x plus, plus 2, is it? Plus 4. Minus 4 whole. Times pi. 320.164. Okay. All right. All right. All right. I want you to do number 4 now. Do number 4. G of, what was I going to say? ln, when you're graphing ln, it's kind of a crazy graph. So just sketch it. Just give me a sketch. It's just for the main purposes for that one are to see where the top and the bottom is. That's all it is, right? So it's not, I'm not looking for perfection when you're doing a any type of graph. So it's gonna extend like that, kind of. They'll cross over here, right? Natural log doesn't go negative, right? Natural log doesn't go negative on the negative x's because it doesn't exist, right? It doesn't exist. So if like you go to your table if you go to your table, it'll say error, 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 error for everything that's negative because natural log can't, there's no way you can make a negative number using powers. You can't make a number negative by using any kind of powers. You can make it small, you can make it big, but you can't change the sign. So eventually they cross around 8 point something, 7 point something. They cross, and we can find that using the calculator, right? Okay, so this is the green stuff here. Right? So let's set it up. We'll find the bounds a little bit later, but for right now, I just want to find big R and little r. Still dx, right? Top. Yeah, the top's going to be here, right? The top's going to be the blue line. Now you're going to go down because that's the only place you can go, right? You're going to go down. So big R is going to extend all the way until I reach the other side of the green. That's big R, all right? So the top is 6, right? So it's going to be 6 minus, yeah, so you want to use parentheses here. 1/2 x minus 2 because it's minus the whole thing. It's minus the entire thing. Or just make them negative, change the sign. When we put it into our calculator, I'll clean it up a little bit, but not for right now. The other one. There you go. It's going to start at 6, and then it's going to extend down to natural log. Yep. So it's going to be 6 minus natural log of x. Okay. Now the bounds. Where's the left side of the green going to be? 0, right? We just talked about that. Natural log can't go. Natural log doesn't exist on the negative x's, so it has to be 0. And then here, we're going to use the calculator to find that guy there. Right? It's going to be 7 point something, 8 point something. What did you guys get?
So actually, I found out where they intersect. So it was 0.1456. Would that like count as a 0? Or just...
Let's see. Oh, so they intersect before the negative? Oh, okay, yeah, that's important, yeah. Yeah, they intersect before the negative side. So they actually intersect to the right of it, right? So yeah, that's important, yeah. So it's not gonna be quite 0, but yeah. So what'd you get? 0.1456. Good. And then the other side was 8.2109. Okay. All right, put that in your calculator. So when I put it in my calculator, I'm not going to put it exactly like that because, like I said, the calculator sometimes acts a little crazy. I'm going to clean it up a little bit. So I'm going to do what I would do is I would distribute the negative that make that positive. You would have 8, right? So you'd have 8 minus 1/2 x squared minus, and then this guy can't really be simplified. Okay. What do you guys, and then put that in your calculator?
Shouldn't it be 6 instead of 8?
6. Which one's 6? This. You're talking about this guy right here?
Yeah.
So what I did was I distributed the negative, and that made it positive 2. So that became 8. Yeah, that's how it became 8. You don't have to do that, but anytime you can simplify before you put in the calculator, I would do it just because I've just seen over the years that putting more stuff into a calculator sometimes causes the calculator to not respond well. Okay. And then what do you guys get? What'd you guys get with those of you that did it?
I got 312.752.
752. All right. All right, so we'll stop there for today. Tomorrow, what we're going to focus on is revolutions the other way. So revolutions, dy revolutions, right? dy revolutions. Okay, yeah, let me change this to make it. Okay.